This is my video for lab 1 on constant velocity. For the introduction, the main formula used is Newton's second law, which is Vf equals Vi plus F net over m times delta t. And since velocity is constant, F net is 0. So for the overview, first I observed constant velocity of a ball rolling on a table and recorded the ball rolling using Tracker to analyze the motion. Then I created a computer model of the ball's movement using information from Tracker. And then finally I compared the models from Tracker and the model made using Python's glow script. For the Tracker video, I used a ball rolling and I set the axes to be on the origin to be where the ball starts, and then the x-axis is goes to the left in the negative direction. And this is the video of the ball rolling with Tracker. And I set the calibration to have the ball be a diameter of 2 inches. Then for the glow script, I calculated the initial velocity based on the data from Tracker, and an assumption was that friction was assumed to be 0 and the ball didn't slide when it rolled on the table. And also velocity was assumed to be constant, so F net would be 0. And on the right are the graphs of the position time and the velocity time graph that was created from the model. And this is the model versus experiment graph. So the blue line is the model position and the red line is the experiment position. And as you can see, the model and experiment position lines are very close, meaning that the model predicted the movement of the actual ball rolling fairly well. So if the axes for the Tracker software were different, the ball would move in the x positive direction rather than the x negative direction. As you can see in the screenshot from the Tracker software, the origin of the coordinate system is on the ball. So as the ball moves to the left, it goes in the x negative direction. So if it was going in the x positive direction, the graph of the position time would have a positive slope rather than a negative slope. And is it possible for you to say how many pushes and pulls or how many forces are added together to give the 0 net force in the case that you observed? So there is an infinite amount of small forces acting on the ball in order for it to have a net force of 0, because for every small force acting on the ball, there must be an equal force in the opposite direction for the net force to be 0.